So now let's go ahead and start solving some problems. Question 1. Use a 0.05 significance level to test the claim that the samples come from the same population. So the first thing we see are math majors, so that's going to be mu1, our first population, and we can go ahead and put that in first spots of H0 and H1. Next thing we see are English majors, so that's mu2, our second population that's being compared to. We know that H0 can only equal 0, and then let's go back and read it. Test the claims that the samples come from the same population. Same means equal, and we actually already have equal in H0, so H0 is our claim, and if we have equality, then its opposite would be a lack of equality or not equal to. So now we're ready to find our test statistic. Because we are testing means, and in our case, English majors should be independent of math majors, or so one would think, and most of them would argue, we'll be using the z-score or test statistic formula mentioned on the prior video. So now let's go ahead and fill in the parts. So first thing we need is x1, and so for us, x bar 1, the sample mean, is already given to us as 75. We're going to be subtracting x bar 2, which we can see is listed as 70. And then we need to subtract mu1 minus mu2, which we're used to coming up to H0 and seeing what number to use for the population parameter, and we don't see any numbers, but as we've discussed, we're going to use 0. It's always 0 in that position. So you might get into the point where you stop actually writing it. I will always write it for clarity. Now I need to work on the denominator. So I've got the square root. The first thing is sigma squared. So sigma 1 is going to be 15, but I've got to remember to square it. And that is divided by n1, which in this case n1 was up top, and a lot of students get really thrown off because they want to actually have used the 40 prior because it came first, but that's where it goes in the formula. And now I need to finish off my formula. So I'm adding 14 squared all over the different population size of 60. So that's one good thing to point out we haven't discussed. When comparing populations, it would be great if you can get the same sample size. Sometimes it's not possible. And we know the larger the sample, the better. So if we could get more English majors, then let's do that. Okay, so now I've got my formula to type into my calculator. I highly suggest, as always, you try it along with me. So I end up getting 1.67678, etc. I'm going to go ahead and answer with 2 digits to the right of the decimal. That means I'll be rounding on my 7, and because it's followed by a 6, it will round up, and my test statistic is 1.68. Now I'm ready to find the critical value. Didn't mention to use the traditional method, but I've got CV in my answer box. So the critical value always starts with alpha, which is 0.05. Remember, alpha is another name for the significance level. I'm using the z-table. Now, how do I know that? That's what I like about the formula over here, is it starts off with z equals, so I get that reminder that I'm using the z-table. So that finds area to the left, except for, don't forget, we got to focus on the fact that I have a two-tail test. Because I have not equal to, even though it's not the claim, I have a not equal to, which means a two-tail test. So in the z-table, for a two-tail test, I need to divide alpha in half and get 0.025. And the way the z-table works is I'm going to have this amount of area in the left tail, which is the way the table works. So I'm going to go to the z-table looking inside for 0.025. And in row 1.9, it's actually in there. Usually we have to find which number it's closer to, but in this case it was in there. And so that means my critical value is plus or minus 1.96. So even though we found negative 1.96, we've stated that we have a two-tailed test, and so with the bell-shaped z-table, I'm going to have the positive and negative of that value. My critical value is plus or minus 1.96. So now I'm on to part C, the decision maker. So I've got my bell-shaped curve centered over 0, and I want to graph my test statistic and critical values. Since the smallest number is 1.68, that seemed easier to graph first. It's positive, so it's to the right of 0 and kind of doesn't matter where. And I always like to put TS, test statistic, under it, so I remember that's the one I'm comparing. My critical values are positive 1.96 and negative 1.96. And because they're my critical values, I put the CV underneath it. I've also got some color coordination to help me here. Remember, we shade from a critical value to its closest edge. And since my test statistic is not in the critical region, in the shaded region, since he is not shady, I will not reject him. So I need to answer with fail to reject H0. Still listing our H0, even though we're in a different chapter, we're doing a hypothesis test. And whether this is the value that's being claimed or challenged doesn't matter. H0, the known fact, is always the thing that's rejected or failed to reject. So looking at my chart, my claim is H0. I fail to reject H0. So my concluding sentence should start with, there is not sufficient evidence to warrant rejection of the claim that, now I need to go back and read my question. Use a 0.05 significance level to test the claim that, here we go, the samples come from the same population. So it doesn't really even tell me that it's a mean that's being tested. It doesn't tell me any numbers, which are normally things I'm looking for when you guys write this sentence. But I'm going to copy it word for word as I see above. So finishing off my answer box, the samples come from the same population.